Hi everyone. In this video, I am going to explain about programmable array logic design. PAL stands for programmable array logic. PAL stands for programmable array logic. Okay, in this programmable logic devices, there are three types of designing technologies: programmable array logic, programmable logic array, and programmable read-only memory. The difference among these three we have seen clearly in the last video. Programmable array logic. Okay, how I told to remember? So programmable array means a like take and. So that means programmable and gates and fixed or gates. So it has programmable and gates and fixed or gates. Fixed or gates. Okay, that means AND gates we can program like anything. Okay, once it is connected, we can reconnect this AND gates. But whereas once the OR gates are connected, that cannot be reconnected. The structure will be like this. So for example, F is equal to something like A B bar C plus A B bar C plus A B C A B C. Okay, how to connect this? Generally, the structure we follow is A bar. We draw a line, vertical line like this, which gives true form and complement form. Okay, this is the general scenario how we develop a circuit. And B also has a true form and its complement form. And similarly, C true form and its complement form. Okay, now how many AND gates and OR gates required for the implementation of this type of logic circuit? So A B bar C plus A B bar C. This is one AND gate. This is one AND gate, and these two are ARD. These two are ORed. So two AND gates and one OR gate is required. Two AND gates and one OR gate is required. Okay, that's why in the designing we are taking two AND gates. This is first AND gate, and again second AND gate. Okay, we better take AND gates quite far so that the fuses can be connected. Okay, so we have one AND gate and we have second AND gate here. The outputs of these two AND gates are connected to OR gate, whereas the OR gate is fixed. OR gate is fixed. We cannot change it. Okay, now how many total number of inputs are there actually? Actually it is A, B, C, but by taking A bar, B bar, C bar also, total 6 inputs are there. So all these 6 inputs will have the connection with the gate. That means each AND gate is a 6 input AND gate. Each AND gate is a 6 input AND gate. And all these inputs are connected through a fuse. Remember, all the AND gates are connected through a fuse. This fuse is connected whenever it is required, otherwise it is open circuited. Okay, so what is the expression for the first AND gate? A B bar C. A B bar C. That means A is connected through a fuse. This is the fuse symbol S. B bar C. B bar means this one, B bar and C. This is the way how to connect AND gates, a programmable AND gate in PAL. See here, AND gate is programmed. See, once this operation is completed, if you want to generate one more SOP, then you can remove this fuse and connect whatever you want. Okay, that's why all 6 inputs are directly taken with the help of fuses. And similarly here also we do the same thing. So we are taking all these 6 inputs to the input of AND gate, and whichever is required, that is connected through a fuse. But OR gates, if you see OR gates, it doesn't have any such programmability. All these are connected directly. OR gate is fixed. That is the reason OR gate is fixed and AND gate is programmable. Okay. Now what is our second expression? A bar BC. A bar means this one, A bar B C. Okay. That's why it is A bar BC. So these two are connected to OR gate and produces the output F. So here it is fixed OR gate, or we can say fixed OR array, and it is programmable AND array. Programmable AND array. See, all these inputs, suppose I have 5 number of inputs. Let us consider 5 inputs are there, A, B, C, D. A, B, C, D. 5 A, B, C, D, E. 5 inputs are there. If 5 inputs are there, how many inputs gate we should consider? 5 inputs means 5 into 2, because 5 true forms and 5 complement forms. So 5 into 2 means total 10 number of inputs we have to consider. All these 10 inputs are appearing at the input of the gate. So 10 input and gate we should take. So likewise, if you increase the number of inputs, the number of inputs to the gate also increases. That is somewhat a problem to show and to draw. That will become a complex logic circuitry. So in order to avoid such a situation, the modified and simplified circuit will be like, as the number of inputs increases, as the number of inputs increases, the gate complexity, gate means AND gate here, complexity also increases. AND gate complexity also increases. So the modified or simplified design of PAL is like C. Now similarly we will consider A bar B bar C bar. Input is common, so total 6 inputs. So for 3 inputs, total 6 along with its 2 and complement forms. And now we are taking AND gate, normal AND gate. How many AND gates are required? 2 AND gates are required. See here, see the size of the AND gate. Previously we have drawn this much big size of AND gate because it has to accommodate all the 6 inputs. But here we are drawing a single line. We are drawing a single line to the input of AND gates. We are drawing a single line to the inputs of AND gates. That single line shows multiple connections whichever is required. Okay, this is for showing. That means this is for showing a simple example of the PAL. But internally, all these 6 inputs are connected together. See, what is the expression for the first one? A, B bar C. And what is the expression for second one? A bar B C. Okay, so A, B, where is A? Here it is A. So take a fuse connection. This cross mark indicating fuse. Cross mark indicating the fuse. Nothing but connection. Nothing but connection. When there is no fuse or no cross, there is no connection. Okay. And one more is B bar. Where is B bar? This is B bar. Another one is C. This is C. That means A, B bar, C. These three are connected from this AND gate. And similarly for this AND gate, A bar, B, and it is C. So A bar, B, C. These are the outputs. Okay, this is the simple way of showing AND array. This is the simple way of showing AND array. This particular method is the programmable AND array. Programmable AND array. Okay, programmable AND array. It is very easy. Whenever it is not required, simply we are just removing the cross mark. A cross mark is nothing but there establishes a connection between vertical and horizontal line. Cross mark is nothing but it establishes a connection between vertical and horizontal line. Okay, simply if a cross mark is removed, then there is no connection. Whichever is required, then again we will shift that particular point to that. Okay, and coming to the OR gate is fixed, so we are taking OR gate like this. Okay, and suppose you may have to ask that if n number of inputs are increased like this for the OR gate, then what about the OR gate size? That means suppose if he as it is here only two inputs are there, two input OR gate is considered. Let it be 10 inputs, 10 product terms. Then all these product terms can be connected to a single OR gate that will be the 10 input OR gate, or is there any other way? There is also another way by connecting all these vertically as a single point and connect together. Okay, I will draw that. OR gate can also be simplified as shown. A bar, B, B bar, C, C bar. I can show all these in one circuit diagram, but for better understanding, I'm separating the circuits. Okay, so what we have taken, one AND gate here, another AND gate here, and this is the input for the AND gate, this is the input for the second AND gate, and now these two are, see, these two are joined together. Suppose if 10 number of AND gate outputs are there, all these are joined here like this vertically. Now, just this particular input is connected to OR gate. This particular input is connected to OR gate. This is the F. Okay, whichever AND gate output is there, suppose if two OR gates are there and two more AND gates are there, so this joined together and giving to OR gate. This is then F1 and it is F2. Okay, these gates are having inputs like this. Okay, gates are fixed here. So depending upon the connections, we are connecting like this, whatever it is required. I'm just randomly drawing whichever is required. Okay, so they are connected like this, and the corresponding product term is coming are added up and produces the function F1 or F2. Okay, this is the way of designing a programmable array logic using this AND or invert logic. Actually, all these are AND or invert logic only. This is AND or invert logic, because if you see all these three will appear in this. See, this is AND gate, this is OR gate, and inverters are of course they are in the input form. Okay, this is the programmable array logic. Don't confuse, this is programmable array logic. When you go to the programmable logic array, as both are programmable, OR gates will be in the downwards. Okay, vertical lines we will draw and OR gates will be coming in the downwards, so that can also be programmed. Okay, and one more is there, programmable array logic table, PAL table, that I will explain with an example in the next video. Thank you.